What Greek mathematician wrote the book Elements?
The Greek mathematician and geometrician Euclid, c. 325 c. 270 BCE, made some of the most significant improvements to geometry in his time. For more about Euclid, see History of Mathematics and Foundations of Mathematics. One contribution was his collection of 13 books on geometry and other mathematics. Titled Elements, or Stoicheion in Greek. This work has been called the world's most definitive text on geometry. The first 6 books offer elementary plane geometry, with sections on triangles, rectangles, circles, polygons, proportions, and similarities. The rest of the books present other mathematics of his day, including the theory of numbers, books 7 to 10, solid geometry, pyramids, and Platonic solids. These books were used for centuries in Western Europe, in fact. The elementary geometry many students learn in high school today is still largely based on Euclid's ideas on the subject.
What is the definition of a modern computer in today's sense of the word?
In general, and simply put, a computer is a machine that performs a series of mathematical calculations or logic operations automatically. Computer specialists often divide computers into 2 types. An analog computer operates on continuously varying data, a digital computer performs operations on discrete data. The majority of today's computers easily process information much faster than any human. The response, output, of a computer depends on the data input of the user, usually controlled by a computer program. A computer also can perform a large number of complex operations and can process, store, and retrieve data without human interference. There is a great deal of overlap for the word computer. In a more archaic sense, a computer is called an electronic computer, or computing machine or device. The more common expressions include data processors or information processing systems. But remember, there is a definite difference between a computer and a calculating machine. A computer is able to store a computer program that allows the machine to repeat operations and make logic decisions.
How did symbols for unknowns and knowns in algebraic equations develop?
In 1591, François Vite was the first to write and solve general algebraic equations by introducing the systematic use of letters as algebraic symbols. He used vowels, a, e, I, o, u, for the unknowns and consonants. The rest of the alphabet, for the coefficients, or knowns. But it was René Descartes who introduced a new way of using letters in the alphabet in his work La Géométrie. He used the letters at the end of the alphabet, X, Y, For unknowns and the beginning of the alphabet. A, B, for knowns, in many instances, these letters are italicized. This standard is still used in algebra today.
What are some standard measurement units and their definitions?
For a helpful list of standard measurement units and systems for converting them to other types of units, see Appendix 1 in the back of this book.
What problems were computers originally invented to solve?
Originally, computers were invented to solve numerical problems. Now, very few mathematicians, scientists, computer scientists, and engineers can imagine a world without computers. Advances in technology have also led to an increase in accuracy, the number of problems that can be solved, and the speed in solving those problems saw far cry from the earliest computers.
What is arithmetic?
Arithmetic is a branch of mathematics that deals with numerical computation, specifically. It includes computation using integers, rational numbers, real numbers, or complex numbers. The word arithmetic has its roots in the Greek word for to count. Arithmein, also arithmos, or number. Arithmetic contains all the rules for combining two or more numbers. In most cases, when mathematicians talk about elementary arithmetic, they are speaking of those subjects most of us learned in grade school: addition, subtraction, multiplication, and division being the most common, and fractions, geometry, and measurements. Ratios and proportion, simple probabilities, and algebra examined in more advanced levels. For even more advanced students, such arithmetic lessons as congruence calculation, root extraction, power computations, and advanced factorizations are often presented.
What are the oldest surviving counting boards?
To date, the oldest surviving counting board is the Salamis tablet. Discovered in 1846 on the island of Salamis, it was once thought to be a gaming board. But historians have since determined that the white marble slab was actually used to count items. The tablet, which measures 59 inches, 149 centimeters, in length, 30 inches, 75 centimeters, in width, and is 1.8 inches, 4.5 centimeters, thick, was used by the Babylonians around 300 BCE. It contains 5 groups of markings, with a set of 5 parallel lines equally divided by a vertical line in the center. Below that is a group of 11 parallel lines, all divided by a perpendicular line. But this was not the only counting board of that time. After the Salamis tablet was developed, the Romans brought out the calculi and the handabacus around 300 BCE to 500 CE. These counting boards were made of stone and metal. One example of a Roman abacus had 8 long and 8 short grooves arranged in a row. Beads would slide into the grooves, indicating the counted units. The longer grooves were marked I to indicate single units, X to indicate tens, and so on up to millions. The shorter grooves were used to indicate multiples of 5, 5 units, 5 tens, and so on. There were also shorter grooves on the right side of the abacus, which were probably used to indicate Roman ounces and for certain weight measurements.
How did the Sumerian written counting system change over time?
Around 3200 BCE, the Sumerians developed a written number system, attaching a special graphical symbol to each of the larger numbers at various intervals, 1, 10, 60, 3600, etc. Because of the rarity of stone, and the difficulty in preserving leather, parchment, or wood, the Sumerians used a material that would not only last but would be easy to imprint, clay. Each symbol was written on wet clay tablets, then baked in the hot sunlight. This is why many of the tablets are still in existence today. The Sumerian number system changed over the centuries. By about 3000 BCE, the Sumerians decided to turn their numbering symbols counterclockwise by 90 degrees. And by the 27th century BCE, the Sumerians began to physically write the numbers in a different way. Mainly because they changed writing utensils from the old stylus that was cylindrical at one end and pointed at the other to a stylus that was flat. This change in writing utensils, but not the clay, created the need for new symbols.
What are the two ways of looking at the derivative?
There are two major ways of looking at the derivative: the geometrical, or the slope of a curve, and the physical, the rate of change.
Why are some prefix names different in measurements?
The main reason why a prefix name would differ has to do with pronunciation and vowels. If the first letter of the unit name is a vowel and the pronunciation is difficult, the last letter of the prefix is omitted. For example, a metric measurement of 100 aries, 2.471 acres, is a hectare, not hectare, and 1 million ohms is a megohm, not megaohm. There are exceptions, though, especially if the resulting prefix and unit sound fine, such as a milliampere. There are even times that another letter is added to make it easier to roll off the tongue. For example, the letter L is added to the term for 1 million ergs, making it a megalerg, not a megaerg or megerg.
What is a magic square?
A magic square is an array of numbers in an n by n square that contains positive integers from 1 to n2 with each number occurring only once. The numbers in the squares are arranged so that the sum in any horizontal, vertical, or main diagonal direction is always the same. This is shown in the following formula: n2 plus 1, / 2. Magic squares are often divided into orders. For example, a 3-order magic square means 3 boxes per row and 3 boxes per column. In reality, magic squares are actually matrices. For more information about a matrix, see algebra. They can be odd order, such as a 3 by 3, or 5 by 5 matrix, or even order, such as a 4 by 4 or 6 by 6 matrix, magic squares. Perhaps the simplest magic square is the 1 by 1 square, whose only entry is the number 1. Such magic squares have been known for centuries. For example, the Chinese knew about the 3 unique normal squares of order 3. In Chinese literature dating from as early as 2800 BCE, a magic square known as the Lo Shu, or Scroll of the River Lo, was invented by Fa Hai, who is thought of as the mythical founder of the Chinese civilization.
What is an angle?
An angle is a major concept in both geometry and trigonometry. An angle is formed by 2 rays that begin at the same point. A straight angle is one in which the 2 rays lie on the same line. It can also be described as 2 planes coming from a common line. Angles are named in several ways: a capital letter at its vertex, the common points for both rays. See illustration, LB, a small letter within the angle, a number within the angle, or by 3 capital letters. ABC or CBA, with the middle letter representing the vertex and the other 2 points the rays. The 2 rays that form the angle are called the sides of the angle, such as side BA and side BC.
How do surveyors use mathematics?
Surveyors use mathematics, especially geometry and trigonometry, because they need to measure angles and distances on the ground. They then interpret the data, accurately plotting such information as boundaries and locations of structures on a map. These maps are then used for personal or legal means, such as a survey of a person's lot showing ownership boundaries in order to obtain a mortgage. The traditional method of surveying is called plane surveying, which does not take into consideration the curvature of the earth because, for most small projects, this curvature doesn't really matter. When it does, especially for projects measuring greater distances, the method used is called geodetic surveying.
What are lateral surface areas?
In many mathematical texts, the lateral surface area, L A, is given along y there instead of the surface area, SA. This type of area is the surface area of a three-dimensional figure, excluding the area of any bases. In other words, the lateral surfaces are the side faces, or surfaces, of a solid, or any face or surface that is not a base, or bottom of a figure.
What is reliability?
Industrial engineers use another type of statistical technique called reliability. A system that always produces the same results and that hopefully meets or exceeds its specifications. A product is analyzed using the reliability function, or survivor function. The probability of a unit in a system that does not fail in a certain specified time interval. If the unit does fail in a system, it means the end of the unit's ability to perform the required function. This is determined by the failure distribution function, or the probability of an item failing in a specific time interval. Calculations involving the common failure rates of various mechanical devices often results in a graph with a bathtub-shaped curve.
What does the term statistically significant mean?
For most of us, significant means important. In statistics it means probably true, not due to chance, but not necessarily important. In particular, significance levels in statistics show how likely a result is due to chance. The most common level one thought to make it good enough to believe is 0.95. Which means the finding has a 95% chance of being true. This can also be misleading, however. No statistical report will indicate a 95%, or 0.95, in its answer. But it will show the number 0.05. Thus, statisticians say the results in a backward manner. They say that a finding has a 5% chance of not being true. To find the significance level, all one has to do is subtract the number shown from 1. For example, a value of 0.05 means that there is a 95%, 1. 0.5 equals 0.95, chance of it being true. For a value of 0.01, there is a 99% chance. 0.01 equals 0.99, of it being true, and so on. Bar graphs are similar to histograms, but with the columns separated by each other by small distances. They are commonly used for qualitative variables. A pie chart is another way to represent data graphically. In this case, it is a circle divided into segments, or pie wedges. Each segment represents not only a certain category, but its proportion to the total set of data. Another type of graph is the line graph, which is similar to those seen in geometry. A representation of the data from connected point to connected point. They are one of the most common graphs seen for simple statistical data collection.
What is the scale of a map?
Most travel, street, or highway maps show a measurement scale, usually in terms of miles and kilometers. To determine a straight line, horizontal, distance on a map. Take a piece of paper and mark the origin and destination as tick marks on the paper. Then measure the distance between the tick marks based on the map scale to find the distance in miles or kilometers. Topological maps also have scales, but in this case the scale is a ratio representing the measure on a map to some number of the actual units of measure on the Earth's surface. For example, a map with a scale of 1:25,000 means that 1 inch on the map is equal to 25,000 inches on the ground. Because both numbers have the same units, it can also be interpreted as any unit measure. For example, the same map could also be interpreted as 1 centimeter equals 25,000 centimeters on the ground, or 1 meter equals 25,000 meters, and so on. For those who prefer to measure in miles and kilometers. Most topographic maps also offer a graphic scale in the legend. For more about scales, see Math in Engineering.
When did geometry originate?
The field of geometry was probably developed by several cultures over millennia, but only in crude, elementary forms. Some of the first to actually work with geometry were the cultures of the Mesopotamian region around 3500 BCE, especially the Babylonians. They were the earliest peoples to know about what is now called the Pythagorean theorem. In fact, the Greek mathematician and philosopher Pythagoras of Samos c. 582 c. 507 BCE may have actually learned about this theorem in his travels to the east. And they possessed all the theorems of plane geometry that the Greeks attributed to Thales. The Egyptians came next, using geometric methods mainly for construction of huge monuments. This included the sundry pyramids and monuments of the region, some of which still dot the landscape today, a tribute to their builders who used geometric techniques.
What is the geologic time scale?
The geologic time scale is a way of managing large amounts of time in a convenient chart. The scale is actually a measurement encompassing the entire history of the Earth from its beginnings some 4.55 billion years ago to the present day. The largest divisions include eons, eras, and periods. The smaller time divisions include epochs, ages, and subages.
What is a population pyramid?
A population pyramid is actually two back-to-back bar graphs that show the distribution of a population by gender. One shows the number of males and the other shows the number of females. Most often in 5-year age groupings. These pyramids take a variety of shapes. For example, a triangular population distribution, also called a pyramid or exponential distribution, is usually indicative of a high birth and death rate, and a short life expectancy that is typical of less economically developed countries. A rectangular population distribution pyramid shows little change in size between the age groups. With more people reaching old age, this is typical of a more economically developed country. There are several uses for population pyramids. Besides calculating life expectancies, they are often used to find the number of dependents being supported in a specific population. Dependents in this case are considered to be children under 15, those attending school full-time and unable to work, and those over 65 years old or retired. Although this is a general definition and not applicable in all cases in all countries. Thus, governments can use such graphs to determine how much of the working population can support dependents. The graphs are also used to help predict future changes in terms of decades of a population's age structure. Historians use them, too, to find significant information based on past population pyramids.
Is it easy to figure out the size of a distant object?
Yes, it is often possible to figure out the size of distant objects, as long as they aren't too small. The key is in knowing the distance to the object. For example, if someone holds a nickel at arm's length and then has someone hold the nickel 200 yards away, the coin may appear to be smaller, but its size really hasn't changed. If a person knows how large an object appears to be, and how distant it is, they can work backward to determine the true size of the object. Simply put, this is also how astronomers work out the size of distant objects in outer space.
What are independent events in probability?
In probability theory, events are independent if the probability that they occur is equal to the product multiply together of the probabilities of either two or more individual events. This is also often called statistical independence. In addition, the occurrence of one of the events can give no information about whether or not the other event, S, will occur, that is, the events have no influence on each other. For example, two events, A and B, are independent if the probability of both occurring equals the product of their probabilities, or P, A, P, B. The symbol is often used to depict the product of the events in probability theory. One good example involves playing cards. If we wanted to know the probability of two people each drawing a king of diamonds, two independent events, it would be defined as A equals 1/52nd, the probability that one person will draw a king of diamonds, and B equals 1/52nd, the probability that the other person will draw a king of diamonds. Assuming the first person puts the first drawn card back into the deck. Substituting the numbers into the equation, the result is 1/52nd equals 0.00037. Or a slight chance that both people will draw the king of diamonds from the deck.
What are the solutions relative to differential equations?
There are three types of solutions when discussing differential equations. General solution. This includes the solutions obtained from integration of the differential equations. In particular, the general solution of an nth order ordinary differential equation has n arbitrary constants from integrating n times. Singular solution. Solutions that can't be expressed by the general solutions. Particular solution. Solutions obtained from giving specific values to the arbitrary constants in the general solution.
What is number guessing?
Number guessing is a game, some say trick. Some people can do number guessing in their heads, as long as the numbers are kept small. Have a person think of any positive integer n, not 0 or any negative numbers, and apply the following steps. For example, a person chooses the number 25 and keeps that number to humor herself. Ask the person to compute 3xn, 3x25 equals 75, ask if the number is odd or even. Odd. If the number is even, tell him or her to divide the number by 2, if the number is odd, tell him or her to add 1 to the number, then divide that number by 2. 75 plus 1 equals 76 halves equals 38, tell him or her to take that number and multiply by 3, then divide by 9. 38x3 equals 114/9 equals 12.666. Take that number and multiply by 2, 12.666, x2 equals approximately 25. The answer should be the original number or close to it.
What are some types of mathematical models?
Mathematical models are commonly broken down into numerical or analytical models. Numerical models are those that use some type of numerical timing procedures to figure out a model's behavior over time. The solution is usually represented by a table or graph. An analytical model usually has a closed solution. In other words, the solution to the equations used to describe changes in the system can be expressed as a mathematical analytic function. Mathematical models can also be divided in other ways. For example, some models are considered deterministic, or a model that always performs the same way for a given set of initial conditions, or stochastic, or a model in which randomness is present.
What are the odds when playing craps?
Craps is probably the most popular game of chance in the world. It is also illegal to play in many places. But it has a long history. It was played in ancient Greece and Rome and was even a mainstay of some old 1930s and 40s movies. Craps can be played using a wall and a pair of dice. It is a popular casino game in places such as Las Vegas and even on the internet, with betting on craps involving a complex equation. Its popularity no doubt comes from its simplicity. In craps, a player throws two dice. Their number, roll, is the total of the dots on the top faces of the dice. If the initial roll is a 7 or 11, called a natural, the player wins. If the number 2, 3, or 12 comes up called craps, the player loses, but keeps the dice. If the sum of the dice adds up to the number 4, 5, 6, 8, 9, or 10, that number becomes the thrower's point. The player then continues to shoot until he or she throws the point number again, in which case the gambler wins and retains the dice. But if the player shoots a sum of 7 before he or she can roll the point value, he or she loses and gives the dice to the next player. Craps is truly a game of chance, with the probability mathematics of craps fairly straightforward. For example, take the probability of winning on a roll-by-roll basis, in which p equals n, is the probability of rolling a point n. The resulting numbers show that the probability of winning is 244/495. Or the shooter wins about 49.2929% of the time.
How can the base of logarithms be changed?
The base of logarithms can be changed from one that is not 10 or e to an equivalent logarithm with base 10 or e. The following gives the formula for such a transition, in which a, b, and x are real positive numbers, but neither a nor b are equal to 1, and x is greater than 0. Convert log x to the base b by using the formula, logs, log b.
What are geometric postulates?
Similar to other parts of mathematics, there are many geometric postulates. or statements that are assumed to be true without proof. From these postulates, theorems, another type of mathematical statement, can be proven. In addition, theorems are proven by definitions or previously proven theorems. An example of a postulate in geometry is, through any 2 points there is exactly one line. Another is, if 2 points lie in a plane, then the entire line containing those 2 points lies in the plane.
How is the area determined for some common two-dimensional polygons?
Finding the areas of polygons is not as simple as determining the areas of a rectangle and square. In order to find the area of certain polygons, one essentially breaks the shape down into smaller shapes with simpler formulas. These types of shapes are called composites. The formulas for many of these polygons are all adaptations from the rectangle area formula, or height, h, times base, b. For example, a triangle is actually exactly half of a rectangle. Thus, the formula to find the area of a triangle is half the base times the height, 1/2bh. In the case of the trapezoid, the figure can be divided into triangular sections, with the area equal to 1/2 times the 2 bases times the height, or 1/2, b and b, h. The triangle formula also is used to find other regular polygon areas, but they are less obvious. For a regular polygon, a feature called the apothem is necessary for finding the area. This is the height of one of the congruent triangles inside the regular polygon. In general, to find the polygon's area, you need to find the area of one triangle and multiply it times the number of sides. For example, to find the area of a hexagon, divide the figure into 6 triangles, each with L equal to the height of each interior triangle or apothem. L is also half of the smallest interior dimension of the hexagon, called W. Thus, the area of a hexagon is the square root of 3 divided by 2 times W squared, or V3-2xW2. There is still another way to determine the area of a polygon by using the Pythagorean theorem. A method that uses length and height, with the resulting formula for the area of a polygon looking much different. Both methods give the same results in numerical terms. For example, the area of a hexagon using the smallest interior dimension would be 0.866 times the square of the smallest width, W. The area of a regular hexagon using the Pythagorean theorem is 2.598 times the square of its side length. These may be different ways of presenting the solution, but both give the same correct area measurements.
What is the graphic representation of the approximation of an area under a curve using integration?
It's easier to see the approximate area under a curve using integration by means of graphs. It all has to do with rectangles. The idea is to extend lines from the ends of the curve, here, f, x, to the z-axis, or y-axis, depending on the curve. We'll call the total area under the curve n, then divide the entire area under the curve into equal width sections. x1, x2, x3, and so on, that are equal to parts of n, the subregions n1, n2, and so on. The next step is to figure out the area of a rectangle if each section was cut off below the curve and then above the curve. This creates rectangles defined by left-hand right endpoints. From the left-hand right sums, and a few more calculations, we can approximate the area of n.
What are quantitative and qualitative variables as used in statistics?
Variables are values used to come to conclusions in a statistical study. There are two main categories, quantitative and qualitative variables. Quantitative variables can be divided into three types. Ordinal variables are measured with an ordinal scale, in which higher numbers represent higher values. Even though the intervals between numbers are not necessarily equal. For example, on a 5-point rating scale measuring attitudes toward cutting back on air pollution, the difference between a rating of 2 and may not be the same as the difference between a rating of 4 and 5. Interval variables are measured with an interval scale, in which one unit on the scale represents the same magnitude of the characteristic being measured across the whole range of the scale. For example, the Fahrenheit scale for temperature is an interval scale, in which equal differences on this scale represent equal differences in temperature. But a temperature of 30 degrees is not twice as warm as one of 15 degrees. The third type is the ratio scale variable. This is a scale similar to the interval scale, but with true 0 points. For example, the Kelvin temperature scale is a ratio scale because it has an absolute 0. Thus, a temperature of 300 Kelvin is twice as high as a temperature of 150 Kelvin. Qualitative variables are measured on a nominal scale, or a measurement that has assigned items to groups or categories. With these variables, there is no quantitative information and no ordering of the items is conveyed. It is qualitative rather than quantitative. Religious preference, race, and gender are all examples of nominal scales.
Who was Baron Gottfried Wilhelm Leibniz?
A contemporary of Isaac Newton, German philosopher and mathematician Baron Gottfried Wilhelm Leibniz. 1646 to 1716, is considered by some to be a largely forgotten mathematician. Although his contributions to the field were just as important as Newton's in many ways. He is often called the founder of symbolic logic. He introduced the terms coordinate, abscisses, and ordinate for the field of coordinate geometry. He invented a machine that could do multiplication and division. He discovered the well-known series for pi divided by 4 that bears his name. and he independently developed infinitesimal calculus and was the first to describe it in print. Because his work on calculus was published 3 years before Isaac Newton's. Leibniz's system of notation was universally adopted.
What is linear algebra?
Linear algebra is the study of linear sets of equations. It encompasses their transformation properties and includes the analysis of rotations in space. Least squares fitting, and numerous other problems in mathematics, physics, and engineering.
What is the probability of drawing a diamond card or an ace from a pack of 52 playing cards?
The probability of drawing a diamond-faced card from a pack of 52 playing cards is easy to determine. Since there are 13 diamond-faced cards in the deck, the probability becomes 13 50/2 1/4 equals 0.25. The probability of drawing an ace from a pack of 52 playing cards is also easy to determine. There are 4 aces in the deck of 52 cards, thus, the probability becomes 4 50/2 equals 1/13 equals 0.076923. This represents a much lower probability than drawing a card in a specific suit, illustrated in the preceding example.
Why was Max Planck important to quantum theory?
Quantum theory, or physics, entails the emission and absorption of energy by matter and the motion of material particles. It is a special situation in which very small quantities are involved. When added to the theory of relativity in which great speeds are involved, both form the theoretical basis of modern physics. One of the most important aspects of quantum theory is the quanta. In 1900, German physicist Max Carl Ernst Ludwig Planck, 1858 to 1947, proposed that all forms of radiation such as light and heat come in bundles called quanta. These bundles are further emitted and absorbed in small, discrete amounts, thus behaving in some situations like particles of matter. For example, a bundle of light energy is known as light quanta or photons. Planck devised the equation, E equals hv, in which E is the amount of energy in a single particle. V is the frequency of the wave, and h is the constant now known as Planck's constant. It is interesting to note that some people divide physics using Planck's discovery. The term classical physics is often referred to as before Planck, while the term for modern physics is often referred to as after Planck.
What is conditional probability?
Conditional probability is often phrased as event A occurs given that event B has occurred. The common notation is a vertical line, or AB, set as a given B. Thus, P, A denotes the probability that event A will occur given that event B has occurred already. Since there is always room for improvement even in probability, conditional probability incorporates the idea that once more information becomes available, the probability of further outcomes can be revised. For example, if a person brings a car in for an oil change every 3,000 miles, it can be calculated that there is a probability of 0.9 that the service on the car will be completed within 2 hours. But if the car is brought in during a seatbelt recall, the probability of getting the car back in 2 hours might be reduced to 0.6. This is the conditional probability of getting the car back in 2 hours if there is a seatbelt recall taking place.
What does Einstein's famous equation E equals mc2 signify?
Among his other accomplishments, Albert Einstein showed mathematically that there was a connection between mass and energy. Energy has mass, and mass represents energy. This equation, also called the energy-mass relation, is expressed as E equals mc2, in which E is energy, m is mass, and c is the speed of light. Because c is a very large number, even a very small amount of mass represents an enormous amount of energy.
What is a transit?
The transit, or adiator, is credited to J. Transit of France, who invented the device in 1889. He called it his arithmography. In actuality, his work was based on earlier designs that were first started by Claude Peyroux 1613 to 1688. It was used principally for addition and subtraction. A transit's flat, mechanical, palm-held calculator had three main components. The part for the calculation, a stylus, and a handle to reset the adiator. By inserting the tip of the stylus into notches along a metal plate, numbers could be added by sliding either up or down strips of metal with numbers marked on them. No gears or interlinked parts were involved. To carry one when the sum of two digits was greater than 10. The stylus was moved up to and around the top of the device.
What is a vector?
A vector is considered to be an element of a linear or vector space. A vector is different than a point, as it represents the displacement between 2 points, not the physical location of a point in space. Vectors also define a direction, points do not. Vectors are usually represented by a line segment in a specific direction on a graph, with an arrow at one end of the segment.
What is the variance?
The variance is the average of the squares of a set's deviations. It is used to characterize the spread among the measures of a given population. First, calculate the mean of the scores, then measure the amount that each score deviates from the mean. Finally, square that deviation, in other words, multiply it by itself. Add all of them together, then divide by the total number of scores.
What is an angstrom?
An angstrom, is a unit of measurement often used in chemistry, most often in reference to molecules. For example, the average molecule diameter is between 0.5 to 2.5 angstroms. An angstrom is equal to about 3.937 x 10 to 9 inch or 1/100th of a millionth of a centimeter, 10 to 8 centimeter. For more information about measurement, see Mathematics in History.
Who was the first mathematician to write and solve general algebraic equations?
French mathematician François Vite, 1540 to 1603, also known as Franciscus Vita, is often referred to as the founder of modern algebra. He was not a professional mathematician, but he contributed a great deal to the understanding and spread of modern symbolic algebra. Although some of his work paid tribute to ancient mathematical traditions, Vite created a kind of new math. It was not one based on the traditional geometric visualizations, but rather expressed as abstract formulas and general rules. But Vite still divided algebra into distinct branches partially derived from Greek mathematics. Zetics, translating a problem into an equation. Poristics, proving theorems through equations, and exegetics, solving equations. He also was the first to combine algebra with geometry and trigonometry. For more about Vite, see History of Mathematics.
What are computer codes and programs?
Mathematics is an important part of computers, because math is used to write computer codes and programs. The codes are the symbolic arrangement of data, or the instructions, in a computer program, a term often used interchangeably with software. The code, also called the source code, or just source, is any series of statements written in some programming language understandable to the user. This source code within a software program is usually contained in several text files. The program is the sequence of instructions, or computations, that a computer can interpret and execute. In other words, most programs consist of a loadable set of instructions that will determine how the computer reacts to user input when the program is running. The connection between codes and programs is often heard by students studying computer science or working professionals, and even in action movies and television programs. As in, I need to add more lines of code to the program.
How are equations with exponents and logarithms solved?
The way to solve an exponential equation is relatively easy. Take the log of both sides of the equation, then solve for the variable. For example, to solve for x in the equation x equals 60, first, take the natural log, ln, of both sides. ln, x, equals ln, 60, simplify using the logarithmic rule number 3, see above, for the left side, x ln, e, equals ln, 60, then simplify again, since ln, e, equals 1 to, x equals ln, 60, equals 4.0943445562, and finally, check your answer. Using log tables or your calculator, in the original equation x equals 60, e 4.0943445562 equals 60 is definitely true. The way to solve a logarithmic equation is equally easy. Just rewrite the equation in exponential form and solve for the variable. For example, to solve for x in the equation ln, x, equals 11, first, change both sides so they are exponents of the base e. ln, x, equals e11 when the bases of the exponent and logarithm are the same. The left part of the equation becomes x, thus, it can be written, x equals e11 to obtain x. Determine the solution for e11, or x is approximately 59,874.14172. And finally, check your answer. Using tables or your calculator, in the original equation ln, x, equals 11, ln, 59,874.14172, equals 11 is definitely true.
What were some early measurements of volume in terms of the gallon?
The names of the traditional volume units are the names of standard containers. Until the 18th century, the capacity of a container was difficult to accurately measure in cubic units. Thus, the standard containers were defined by the weight of a particular substance such as wheat or beer that the container could carry. For example, the basic English unit of volume, or the gallon, was originally defined as the volume of 8 pounds of wheat. Other volumes were measured based on this gallon. Depending on the different standard sizes of the containers. But like most measurements over time, not all gallons were alike. During the American colonial period, the gallons from British commerce were based on dry and liquid commodities. For dry, the gallon was 1/8 of a Winchester bushel, defined by the English Parliament in 1696 as a cylindrical container 18.5 inches in diameter by 8 inches deep, which held 268.8 cubic inches of material. It was also called a corn gallon in England. For liquid, In England the gallon measurement was based on Queen Anne's wine gallon. Also called the traditional British wine gallon, which measured exactly 231 cubic inches. This is why volume measurements in the United States include both the dry and liquid units. The dry units being about 1/6 larger than the corresponding liquid units. By 1824, the British weren't as satisfied with the gallon divisions as the Americans. In response, the British Parliament abolished all the traditional gallons and established a system based on the imperial gallon. It is still in use today, measuring 277.42 cubic inches. With the container holding exactly 10 pounds of water under specific, such as temperature and pressure, conditions.
What are some basic steps to building a mathematical model?
Just like building a physical structure, there are basic steps to building a mathematical model. The first steps are to simplify the assumptions, or to clearly state those assumptions on which the model will be based, including an understandable account of the relationships among the quantities to be analyzed. Second is to describe all the variables and parameters to be used in the model, and identify the initial conditions of the model. Finally, use step 1's assumptions and step 2's parameters and variables to derive mathematical equations.
What is the polar form of a complex number?
The polar form of a complex number is equal to a real number expressed as an angle's cosine, and the imaginary number, I, times the same angle's sine, with the angle expressed in radians. For more about angles, sines, cosines, and polar forms, see geometry and trigonometry. This is seen in equation form as r cos 8 plus I sin 8, in which r is the radius vector, 8 is the angle, and I is the imaginary number.
What are the definitions of chance?
Chance is defined in many ways. For example, chance means opportunity to some, or the chance to do something. Chance can also mean luck or fortune, such as running into someone one has not seen in years by pure chance. Chance also involves taking a risk, which may include some type of danger. Mathematically speaking, chance is a measure of how likely it is that an event will occur, in other words, a probability. For example, if a meteorologist says that a hurricane on a certain path has struck the coast of Florida, say, about 4 times out of 10, then the ratio becomes 4 to 10. With the chance of striking under the same conditions being 40%.
What is currently the most common numeration system?
The most common numeration system in use today is the Hindu-Arabic. This set of numerals has 10 digits in a place value decimal system, which is a fancy way of saying that a decimal system one based on tens is an integral part of the system, and that each number has a certain value depending on its place in the list of numbers.
What are existence theorems?
An existence theorem is one that has a statement beginning with there exist, s. Or, more generally, for all x, y, there exist, s. Existence theorems are presented in several ways, including showing the exact formulas for the solution, describing in their proofs iteration processes how to approach the problem, and by simply deducing the solutions without showing any methods as to how it was determined. Many mathematicians do not believe in existence theorems, stating that any theorems in which entities cannot be constructed are worthless. Other mathematicians cite the existence of such theorems but prefer to use tried and true theorems that offer specific proven methods.
What is a sample space?
In any experiment, there are certain possible outcomes. The set of all possible outcomes is called the sample space of the experiment. Each possible result is represented by one and only one point in the sample space, which is usually denoted by the letter S. To each element of the sample space, or to each possible outcome, a probability measure between 0 and 1 is assigned, with the sum of all the probability measures in the sample space equal to 1.
Who was considered the first statistician?
English statistician and tradesman John Grant, 1620 to 1674, was the first true statistician and wrote the first book on statistics. Although statistics in a simpler form was known long before that. Grant, a draper by profession, was the first to use a compilation of data, which in this case involved the records of bills of mortality, or the records of how and when people died in London from 1604 to 1661 in his natural and political observations made upon the bills of mortality. He determined certain inclinations, such as more boys were born than girls, women tend to live longer than men, etc. He also developed the first mortality table, which showed how long a person might expect to live after a certain age. A concept very familiar to us today, especially in fields such as insurance and health.
What is a sequence?
A sequence is defined as a set of real numbers with a natural order. A sequence is usually included in brackets, with the terms or parts of a sequence, separated by commas. For example, if a scientist collects weather data every day for many days, the first day of collecting can be written as x1 data, then x2 for the second day, and so on until xn, in which n is the eventual number of days. This does not mean that sequences only get progressively larger and smaller. Certain solutions for sequences include a mix of the two.
How are millibars converted to inches of mercury?
Mathematically, the conversion is simple. The air pressure at sea level is 29.92 inches of mercury, or 1013.2 millibars. For example, if you see air pressure of 1016 millibars on a weather map, convert to inches of mercury by multiplying by 29.92, and then divide by 1013.2. The result is 30.00 inches of mercury.
What is information theory?
Information theory is a branch of the mathematical theory of probability and statistics, allowing it to quantify concepts of information. It was formulated primarily by American scientist Claude E. Shannon, 1916 to 2001, who was also called the father of information theory, to explain the aspects and problems inherent in information and communication. In particular, it involves efficient and accurate storage, transmission, and representation of information, such as the engineering requirements and limitations of communication systems. Note: information theory has nothing to do with library and information science or with information technology. In information theory, the term information is not used in the traditional sense. Here it is used to mean a measure of the freedom of choice with which a message is selected from the set of all possible messages. Because it is possible for a string of nonsense words and a meaningful sentence to be equivalent. With respect to information content, information in this sense takes on a different meaning.